Hello everyone, and welcome to my presentation. Today I will be teaching you about different types of nuclear and thermonuclear bombs, as well as how they work. To start off, I'm going to give you a small history lesson before we can get to the chemistry behind these weapons. So let's move back in time to August 6, 1945. Now I'm going to have to start this presentation on a bit of a somber note, because this was a day where the deaths of hundreds of thousands of civilians would occur due to these weapons, changing history forever. At around 8:16 a.m., the U.S. would drop their first ever nuclear bomb, nicknamed Little Boy, on Hiroshima, Japan, killing 140,000 people in only 43 seconds, and another 74,000 in the years that followed the explosion due to radiation. The deaths that happened in the 43 seconds of the explosion were extremely unfortunate. However, they have taught the world a lot about the danger and incredible power of nuclear weapons. To fully understand how this tragedy took place, we need to go a little while back, only a few months before the Hiroshima bombing. The US had just finished constructing their first nuclear bomb. The bomb was made up of uranium, the 92nd element on the periodic table. The way a uranium bomb works is based on a fission chain reaction that occurs between uranium-235 and a neutron. It starts with a neutron hitting uranium-235, which causes more neutrons and fission to occur. These new neutrons can either exit the material, which does nothing, hit uranium-238, which does nothing for this bomb, or hit uranium-235 again, which will cause the whole process to repeat itself, which releases a bunch of energy. Now, to make sure those first two things don't happen, you have to have a large piece of uranium, enough for the uranium to have a critical mass. Then the chain reaction will happen more often, creating more energy. However, you will have to keep the uranium from exploding immediately. To do this, the critical mass amount is divided into two halves, which are pushed together using a normal explosion in a gun-type assembly, causing the bomb to explode only when the user wants it to. That's all for the uranium bomb, so let's move on to another kind of nuke, the plutonium bomb. Now it turns out that while the Little Boy was being developed, another nuclear bomb was also being made, the Fat Man. The Fat Man is actually 40% stronger than the Little Boy, and happened to also be dropped on Japan only 3 days later on August 9, 1945. So, sorry Japan. However, unlike the Little Boy, which is made up of uranium, the Fat Man is a plutonium bomb. Plutonium is actually created when a neutron hits uranium-238. Now, I talked about that process before with the uranium bomb, and even though plutonium's creation process is useless for a uranium bomb, it is obviously crucial for a plutonium bomb. Now, the way a plutonium bomb is actually exploded is similar to the uranium bomb, but not exact, because while the uranium bomb uses a gun-type assembly, the plutonium bomb uses implosion to explode. This is done using many explosions surrounding a plutonium core. When the explosions go off, the plutonium core gets really small, which is another way to get a critical mass. This causes plutonium to basically fall apart, creating energy and eventually the explosion. Finally, let's talk about our first and last thermonuclear bomb on the list, the hydrogen or H-bomb. Now, the hydrogen bomb was actually developed after World War II and is far more advanced than the previous two bombs that I have talked about. They are also way more powerful. Now, unlike the uranium and plutonium bombs, which just use fission to occur, the hydrogen bomb uses both fission and fusion to occur. There are actually two stages of the explosion of the hydrogen bomb. The first stage uses an implosion-style explosion, basically the same as the plutonium bomb. Stage 2 is what makes the hydrogen bomb so powerful. Basically, when the bomb is set off, the implosion of stage 1 happens first, which causes the plutonium to become critical, which releases a bunch of heat and radiation in the form of X-rays. These X-rays then go into this uranium tamper surrounding the inside of the bomb. This causes the radiation to ignite a plutonium spark plug, which is in between rods of lithium-6, causing extreme amounts of heat and pressure. Now, these conditions happen to be perfect for fusion to occur. Because of this, the lithium in the bomb turns into hydrogen and undergoes fission. I know this may all sound confusing, but the bottom line is that this all creates a bomb that is about 1,000 times stronger than the uranium and plutonium bomb. Now, thankfully this bomb has never been used and hopefully will never be used, because if it did, this could very well cause the end of the world. Anyway, thank you all for watching my presentation. I hope this helped you learn something interesting about atomic weapons.